So this section will be about acoustics. In our lab, we're going to look at the intervention in a small building that we've been working on. And so we won't be able to include all of the discussions that we're going to have. So we need to, I guess, kind of punch up the things that won't be covered in our exact lab project. But some of these terms should be familiar to you. A decibel, the level of sound pressure, some things that may not be OSHA. I think it's the Occupational Safety Hazard Administration. They're the workplace governing body for the protection of workers' safety. And a workplace includes an office, a manufacturing environment, many things that we as designers design. And sound is a consideration in safety and hazard in those environments. And then we have the things, the behaviors of sound, refraction, reflection, transmission, absorptivity, and then some of the unique terms that we discuss when we talk about sound, reverberation, and this idea of sound transmission coefficient, the way we kind of measure the motion of sound or the movement of sound through surfaces. So we have this idea of a positive aspect and a negative aspect of acoustics in architecture. So the positive one, obviously, is this idea of creating spaces where a voice can be heard on stage to anyone in an audience, the perfect construction of an acoustical space. Renzo Piano's statement, you feel that your life is being lost in a room where sound dies. We need reverberation. This idea of creating a, a perfect acoustic environment is a nice aspirational goal to this idea of acoustics. But there are other things that we concern ourselves with on a daily basis with this idea of acoustics. So we want to kind of look at these two aspects together. So there's this idea of the definition of sound in general. It's a auditory impression, a tone, something that's perceived by your ears, a sense of hearing. Um, it can also be felt, as we know, in deep bass components. But the sound is many times thought of as the pleasant aspect of an acoustical impression, and the negative one is noise, and that can be road noise, loud conversations in restaurants over and making it difficult to have your own conversations, machinery, hums, things that make it difficult to concentrate on your task. So we're always trying to play up the best parts and play down the worst parts of our noise in our environments. So sound is similar to light. Transmission, reflection, refraction all apply. Long waves and short waves. Um, this says it's unique, but I would argue if you got into the physics of it, it's probably not that unique, but it can be reflected and directed off of surfaces. And that's both a good thing and a bad thing. So we want to be able to control how sound is reflected and directed off of surfaces, and actually concern ourselves with how sound can be refracted around objects, just like light can be. And it can be absorbed, and that's the idea of controlling sound in acoustical environments. So we have just an overview of an ear. Um, I think this is probably covered in most biology classes, but we'll just kind of quickly review it. We have the tympanic membrane, your eardrum. These were referred to at one time as the anvil, stirrup, and hammer of the small bones in your ear that stimulate the cochlea, which has nerve endings in it, and create an electrical neurological impulse to the brain that perceives sound. And the ear is a specifically tuned instrument through evolution. So there are some things to consider about how the ear works. And this is a chart of what's called equal loudness contours. So our ear is very sensitive to sounds that happen in the human speech range, and they are somewhat insensitive to sound in the deeper ranges and very high ranges. And we know that there are other species that have much different kinds of responses to hearing. But these have been adaptations for us as humans, and we need to be aware of that. And one of the things about this idea of the sound pressure level and equal sound is that when sounds are very quiet, we usually just hear these mid-range tones where most of our human speech exists in, and we don't hear the bass very well. It sounds much quieter. So there are many times in amplifier and musical systems where we boost the bass in the treble in order to meet the human hearing thresholds. And I think I'll just wrap up that discussion, and we'll pick it up next in the next clip.